Hello everyone. In this video, we are demonstrating the implementation of digital security door lock system using Verilog HDL on FPGA board. The main objective of this project is to design secure access system where multiple users can unlock a door using their individual passwords. Each user is assigned a unique 4-digit hexadecimal password. The system verifies the entered password and grants access only if it is correct. This system is useful in applications such as laboratories, server rooms, smart homes, banks, and the other restricted areas where controlled access is required. So this is the Verilog code written in Vivado. The design includes the main door logic, which is implemented using the finite state machine along with user selection, password verification, attempt counter, and the 7-segment display control as well, as shown here. Also, the XDC constant file used for pin mapping is shown here. This file defines the connections between FPGA pins and the input-output components on the board. After completing the code, we ran the synthesis process to check for any errors. Once synthesis was completed, run the implementation process. After the implementation was completed, we have generated the bitstream file. After the bitstream file is successfully generated, we open the hardware manager and program the FPGA device, and once the device is successfully programmed, the design starts running on FPGA board successfully. Now here is the demonstration of the system operation. First we select user using the push buttons. Now we enter the correct password using the switches and press the button. So now we can see we have selected user 1 and we are checking the password using the password check button. So we can see the door is unlocking successfully. Now in the second case, we are changing the user but keeping the password same, indicates the wrong password. So I have attempted 3 times. On attempting 3 times, the buzzer will be ringing. So this completes the demonstration of digital security door lock system using FPGA. Thank you.